Another way to solve the same problem would be to convert the mixed number to a common fraction by multiplying the whole number by the denominator and adding the numerator and then putting it back over the denominator of 4. So let's do that. So let's do 4 times 2 is 8. 8 plus 3 is 11. So we can convert 2 3/4 to 11/4. I multiplied the whole number by the denominator, 2 times 4 is 8, and added 3. 8 plus 3 is 11, and I keep my same denominator. So now I'm going to compare 11/4 to 8/3. I can either do this by cross multiplying or by finding a least common multiple of my denominators. I can't compare these as they are right now because they don't have common denominators. So I can see pretty quickly here that I've got a 4 and a 3, and my least common multiple is going to be 12. So I say to myself, what do I multiply the 4 by to get 12? I multiply it by 3, so I do the same thing to the numerator. So now this fraction has been converted to 33/12. And then what do I multiply 3 by to get 12? Multiply it by 4. Whatever I do to the denominator here, I have to do to the numerator so that I'm multiplying by 1 and not changing the value. So I've got 8 times 4 equals 32. 3 times 4 equals 12. And now I've got two fractions with common denominators of 12. And so, in order to see which one's larger, I simply look at the whole numbers that are up in the numerator. And I can see that 33 is greater than 32. So 33/12 is greater than 32/12. And if I work my way back up here, I know that 33/12 is the same as 2 3/4. And so I can change my sign up here. 2 3/4 is greater than 8/3. Let's look at another problem with fractions, mixed numbers, and decimals all in the same problem. Arrange the following numbers from least to greatest. We want to figure out which of these has the largest value and which has the smallest and those in between. So to compare all of these numbers, first we need to convert them all to the same form. And then we'll plot them on our number line and we'll look at which one's the least and which one is the greatest and those in between. So the simplest form in this case is going to be to convert each of these to decimals. And then we'll plot them on our number line and go from there. So 2/8 converted to decimal form is 0.25, or 1/4. 1 1/2 converted to decimal form is 1.5. A little more familiar of a fraction. 7/4 converted to decimals becomes 1.75. And then we've already got our 1.8 in decimal form. So let's plot these on our number line. Our 0.25 is going to lie right here between 0.2 and 0.3. So 0.25 there. 1.5 is clear over here at the 1.5 mark. 1.75 is more to the right than 1.5. And 1.8 is even further to the right here, almost approaching 2. And right there on our number line. So as our numbers increase from left to right on a number line, we can see that these are actually already in order from least to greatest. 0.25 is less than 1.5, is less than 1.75, is less than 1.8. And so I can do the same up here in the problem as it was presented to me. A more difficult approach to this problem would be to convert all of these to fractions and then find their common denominators. So if I were to convert these well, two of them are already fractions, but converting this one this one to a fraction would still stay at 2/8. 1.5, a mixed number converted to a fraction, would become 3/2. 7/4 is already in fraction form. And 1.8 converted to fraction form would be 18/10. Now I see I don't have any common denominators at all here yet, so I can't just go and compare their numerators at this point. I would have to then convert all of these to a common denominator of 80, which would give me 20/80ths for this fraction, would give me 120/80ths for this fraction. This one would convert to 140/80ths. And then we would have this last one here at 144/80ths. Now that we have common denominators, we can look at their numerators and see that they are indeed in order. 20/80ths is less than 120/80ths, is less than 140/80ths, is less than 144/80ths. So either of these methods work. In this particular example, it's a lot simpler the way we did it the first time, converting them all to decimals and looking at them on our number line.